Hi, let's have a look at the problem behind my piano chords test Flutter app. I use the MIDI standard to connect my digital piano with a mobile phone in order to help myself memorize various piano chords. MIDI is a standard that defines, between others, a communication protocol for connecting various audio devices and computers. Let's get into that. First, we need to learn some music theory to understand the problem. Have a look at the piano. It contains a set of white and black keys. Each key represents a pitch that is played. Do you remember the annoying birds screaming on a Sunday morning? Now you can correlate them with different keys. These pitches can be transcribed as notes on a staff. Staff is basically 5 horizontal lines prepared to draw little ants' heads on them. All Western music can be transcribed this way. For example, this key on the piano is represented by this note on the staff. Each note has its name. The names are like an alphabet, just crippled. Instead of going from A to Z, they go from A to G. Our note is called C, actually C4, because it's similar to C1, C2, C3 and so on. C1 has a frequency of 32.7 Hz, C2 double of that, C3 double of C2 and so on, and that makes them sound good together. So we call all of them C. Each note can have an accidental, a sharp represented by a sharp, or flat represented by a strange B. If our note C has a sharp, then it's no longer C but C sharp. On the keyboard, it's the next key to the right. In case of C flat, it's the next key to the left. Notice that C flat is equal to B. Finally, a chord is a combination of pitches, or if you prefer notes, that sound good together. A MIDI standard is a bunch of text defining how stuff should be implemented on a digital piano on my phone so that they can talk to each other. The communication is done through packets of data. A MIDI packet is usually a set of 2 or 3 bytes, so 16 to 24 bits. These data packets carry information such as MIDI commands. For example, a note on command, which could mean that a key on a piano was pressed. These commands are part of the first byte. The second byte carries information about the pitch, so which key was pressed. A note on command is represented by a hexadecimal 9 at the most left 4 bits of the first byte, which is 1001 in bits. The second 4 bits are irrelevant. The second byte of data contains a decimal number between 0 and 227, located at the 7 most right bits. Our C4 note is represented by a decimal 72, which is hexadecimal 48 and 1001000 in bits. To put it together, when my piano sends to my phone a message 100100001001000, I know that someone pressed the C4 key on my piano. There can also be a third byte, but we don't need it. Business logic of this app is concentrated on matching pressed keys with expected notes. The next piece in the puzzle is Flutter. If you never worked with it, pause the video, spend 2-3 days learning and come back. It's simple and it's worth the time. You can check out the code on GitHub or download the app from Google Play and try it out yourself. Follow the links in the description. This has been a problem outline for my piano chords test Flutter app in 3 minutes or less. See you!